Okay, welcome back. So we're looking at question 5 now, just some simple derivatives. And of course this will be about pre-work, won't it? It'll just be about those things that mean that we should just be very careful as we plot through. So 5a is a polynomial. So I'm going to put a symbol, d dx, this whole expression. D dx, everything in the brackets. So I'll get us used to a different set of just writing things out. So 4 comes out the front, 24 x3 minus 18x minus 3. Very straightforward. D dx 9 over x, which is d dx 9x to the minus 1, and that will be equal to minus 9x to the minus 2, which is equal to minus 9 over x squared. So if we take our time, we can resolve everything. 5 root x is going to require some pre-work. So it's going to be d dx 5 root x, d dx 5x to the power 1/2. On differentiation, that'll be 5 on 2 because the half comes out the front. X half minus 1. Now 1/2 minus 1 is 1/2 minus 2 over 2. 1 minus 2 over 2 is minus 1 over 2. So we get 5 on 2 x to the minus 1/2, which resolves to 5 over 2x to the half, which equals 5 over 2 root x. So there you go. Part D, d dx 11 over 2. I like these expressions. X squared, which equals d dx 11x squared, which we now will do the differential. 2 comes out, so 22x x to the minus 2 minus 22x minus 2 minus 1 minus 3, which is minus 22 over x cubed. Either form is okay there for the last two. Just got to watch your minuses, don't you? So for E, we'll be d dxing 5 over the root of x. 5 over the root of x will be some pre-work. I'll write it all again. 5 over x to the half. I'm not finished d dxing yet, because that'll be 5x to the minus 1/2 now. So we can do the differential. Get minus 1/2 times 5 and minus 1/2. That's 1. Minus 1/2 minus 1. So minus 3 on 2. So minus 5 on 2, x to the minus 3 on 2. You can see that calculus doesn't take long, but minus 5 over 2, x to the half. And the final step is minus 5, 2, square root of x. Minus 3 on 2, that's x cubed. Let's watch that little fractional thing there. Minus 3 on 2, to make sure you've got that there. Alright, and finally f. 6 d dx, please. x5 on 4. So we get, we'll do it. 5 on 4 comes out the front. 6x to the 5 on 4 minus 1. Now that's complete. 5 on 4 minus 1 5 minus 4, so we're left with a quarter. Now there's some cancellations here. 2 goes into both of these numbers here, so it's 15 on 2, x to the 1/4, which is the 4th root of x. So we can actually simplify that. It's not a negative, so it's not going down. Okay, so it's the 4th root of x. X to the power 1, so it sits in the 4th root of x. Okay, so fairly straightforward. Alright, so how do we go? Okay, so we've got some product rule to do. Product rule, well, let's have a go at that, 6. So A is x squared. Now you could expand these and make a big polynomial, and you're welcome to do that as a check if you want to. But this is just a way of checking. So what we'll do is here we'll just assign u and b, and so d dx, all of this, will become u db plus b du. Now that's the same as the quotient rule, you just put the minus in. Alright, now we haven't got all of the bits yet, so we can't just go and do equal. So u dash is equal to 2x minus 3, that's that term. And v dash is equal to 3 9s are 27 x squared plus 2. 27x squared plus 2. So now we can say this equals 2x plus 2x minus 3 times 9x cubed plus 27x squared plus 2 and x squared minus 3x. So we've got 2 sets of expansions to do. So 2 9s are 18x4 that's that one. 2x times 2x is 4x squared (3 9s 27) minus 6x. Now doing the expansion here, get 27x4. That's that one. Then we get minus 3 lots of 27x3. 3, 7, 21, carry the 2, 3, 2 is 6, 81. That's the second one. Inside here is plus 2x squared and minus 6x. So we just find all the common algebra and make sure you mark them off as you go. So the highest powers are 4. So 27, so it's 45x4, 18 apples plus 27 apples, minus 27 minus 81, it's going to be minus 108 x cubed in gymnastics, 6x squared (4 apples plus 2 apples) minus 12x. And so that's your final result. Well, your product rules. So polynomial product rules, I'm not sure that they help that much, to be honest. But for the sake of the exercise, we'll go through them. All right, for part B, it's another polynomial, so it's just taking care. All of it is probably anything else. I'm not impressed with myself that I haven't mucked this up yet, but give it a chance. 7x6 plus 4x u v, so u dash will be equal to 20x3 minus 9. B dash will be equal to 42x 5 plus 4. And so the ddx of u times v will be equal to same, just being consistent with how we would do the quotient rule. That's often taught at school that way. So all we've got to do is put them all together now. We get 20 So you've got to do your expansions again. I left them out last time. They're essentially what you're going to do for each of them. And after you've done a couple of rows, you'll get 350 x9 minus 441 x6 plus 100x4 minus 72x. And I'll leave you to do that algebra. Alright, so that's pretty good. All right, now I'll do one of the quotient rules here in the next video. So 7a is 9x minus 3 over 7x plus 2, and of course we can't have 7x plus 2 equal to 0, so that has to be not equal to 0. U b, so u dash is equal to 9, b dash is equal to 7, so y dash is equal to d dx u and v, which will be equal to, now we're going to do the same thing up here, u dash v, and this time it's minus v dash u. Okay, minus v dash u. So we can put that together now. 9 times, oh, forget that, b squared. 9 times 7x plus 2. 7 times 9x. Now, the important thing to remember here is that when you do this expansion, you've got to do minus 7 and 7x plus 2 all squared. So we've got 7 9s are 63x. (63x plus 18). Now, 7 9s are 63. Again. But minus times a minus this time is plus. So it's plus 21. So we end up with minus 63. Unusual, unexpected, but there you go. 21 and 18, 39, unexpected, but that's okay. Alright, I might finish B here now. So we're just up to 18, so that's okay. So we've got 2x3 plus 7x. There's no point trying to fashion some kind of factorising thing. Just go with the flow. 6x squared 7. V dash is equal to 3. So our differential u over v. Did I put that up there? Oh, u over v. You should put it u over v. A bit cheeky, wasn't it? U over v is equal to u dash v plus v dash u over v squared. So we get 6x squared plus 7 times v minus 3 lots of 2x cubed. Over 3x minus 2 all squared. So we can just do the expansion. That's a full FOIL. That's a half expansion. We get 18x cubed minus 12x squared plus 21x plus 14. And don't forget to do that as minus 3, 6x cubed minus 21x all over 3x minus 2 squared. So minus 21x is cancelling. So we end up with 18 apples minus 6 apples is 12 apples minus 12x squared. Unusual, unexpected, but that's okay. Minus 14 all over our square. 3x minus 2. So just taking your time, walking towards your goal, you can get there. I'll be back with the chain rule. See you in part 3.